Alright, testing the sound. Okay. I think it's working. Yep, I think so. Alright, so let's start. Okay, hello everybody. This is Junichiro Horikawa, and this is the weekly Houdini tutorial live that I'm doing. And this is the 26th episode, if this is a series, and the topic today is to create something like deformed gyroid shape like this, which you are seeing in the display right now. So, and I am going to show you how you can create such a geometry parametrically, procedurally, using Houdini. And I said parametric, so that means you can have some parameters in order to change the shape of this geometry itself, the gyroid shape, by using some of the parameters that I've set it here. It is a bit slow because I'm using a BDV at some point, but the output that I got out of this setup is pretty interesting. So yeah, I decided to share the method with you guys, and hopefully you find this interesting as well. You can even change with the shape overall size as well. Yeah, it's a bit slow. Well, still looks interesting. Right, so let's get started. I am going to show you the method from scratch. Let me just place this above my screen so that I can sneak peek. And first of all, I'm going to set up some background color to a dark color. Let me know if you guys can hear my sound, hear my voice, if you are watching it right now. If you can't hear anything, let me just know. Or maybe if you cannot hear, maybe you cannot answer. Okay, so here's my new display, and I am going to show you how I'm going to create this gyroid shape from scratch from now. Okay, so before going and get it into the method, oh, thank you very much for the comment. Looks like it's fine. Oh, and one thing I forgot to mention, you can download the HIP file that I have created previously for this tutorial from the video description page of YouTube that I am streaming right now. So if you're interested, you can download from there. I am also streaming on another platform like Twitter or Facebook, but for those guys, please go to the YouTube page to download the file if you're interested. Right. So before getting into the geometries, how you can make the geometry itself, there are some inspirational image that I got an inspiration from, which as always I was peeking into some of the image in Pinterest, and this is one of the image I found it really interesting, named as differentiated gyroid. If you go to the page which has this image, it is a guy who is working on architectural geometry, I think, and showing some of the interesting shapes. And this is one of the image that this guy has created. Doesn't really show how he created this one, but so that was the start. That was the motivation that I had. I wanted to create something similar to this kind of shape, but it really doesn't show you how you do that. So I have started by looking into the, not this one, looking into the gyroid itself, since it says, at least it says differentiated gyroid, so I guess it's coming from the gyroid itself. So I started by going to this page on Wikipedia for gyroid, and as you might have done it before, some of you might have done it before, the gyroid itself is made of really simple equations, which is this one: sine x cosine y plus sine y cosine z plus sine z multiplied by cosine x equal to 0. So this is the function equations for this isosurface called gyroid. So making just a simple gyroid is pretty simple. So let's start by creating this simple one and try to deform it to make it something like this one. All right. Okay, I have a question. How come you are so good at math? I am not that good at math myself. I just, especially when it gets to like university mathematics, college mathematics, I'm not really good at, like linear algebra. So, but I was using a lot of vector operations, including a trigonometry. So that's the only mathematical functions that I use mostly. So if you just know those stuff, vector operations and trigonometry, it's pretty much enough in order to create some geometrical operations. And if you want to know more, then maybe you can dive into more like linear algebra and so on. And I am also studying it at this point right now, since I wanted to enforce my mathematical skills to create geometry in a more convenient way or efficient way. Right. So okay, so let's start by creating this gyroid shape using these equations, showing it right here. So let's keep this somewhere around here, and let's set the size of Houdini a bit smaller so that I can see the equations on bottom like this. Okay, start by creating a geometry node, and there are mainly two ways to create a isosurface shape like gyroids and Houdini, I think. One way is to use a component called Isosurface, and one way is to use a volume together with the volume wrangle. Either way should be fine, but I found that it's more flexible when it comes to create more deformed shapes or more customized shapes using volumes. So in this tutorial, I'm going to show you how to create a deformed gyroid using volume. But if you want to do the same things in isosurface node, you can also do that. And this isosurface node is pretty simple to use as well when it comes to really simple equations. So let me just show you how to create the gyroid from using isosurface from the start. Okay, so let's click isosurface node, and currently it has a function in order to create a sphere like this, which is x times x plus y times y plus z times z minus 1 to make a sphere with the radius 1. I think that's the radius. Okay, so let's delete this one and put this equations right here for the gyroid to see how it looks like. So sine x multiplied by sine y plus sine y multiplied by cosine z plus sine z multiplied by cosine x. So as you can imagine, the sine and cosines are trigonometry functions. So inside the sine and cosine, you want to input a angle value, and the angle value will create a wave for both sine and cosine between 0 to 360 degrees for one continuous wave. So these x, y, and z value should be, I guess, more than 360 degrees in order to create more than one wave. So, but currently the minimum bound and maximum bound is equal to 1, and inside the expressions, the sign is using a parameter with the degrees. So currently the value x, y, and z is too small. It's in between -1 to +1 degree, so that's obviously too small. So let's make this minimum bound and maximum bound more than 360 degrees to see the difference. So let's say from -1000, -1000, -1000 to 1000, 1000, 1000. So that will be like 3 waves at x, or maybe 6 waves at each axis. Okay, now I see some wavy pattern right here, but as you can see, the density, the resolution is a bit poor, so let's go to the below option. There is the option called divisions, so let's increase this to 50, and now you see some gyroid shape that you see a lot of times, like this. So creating a simple gyroid is pretty simple. You can just input this equations like this, and you can just create a shape like this one. But in order to deform this shape, like the Pinterest image that I'm showing right here, is not simple when it comes to using Isosurface. What you need to do is to kind of modify the value for x, y, or z in order to deform the shape, or use a point wrangle or something to deform the point position. But moving the point position after creating an isosurface is not a good idea, because there's going to be a big chance that you have a self-intersected polygon, so that's not gonna gonna give you any clean polygon. So it's better that you try to deform the shape when you type in equations. So to do that, the isosurface is not good enough, because you have to type all the equations and expressions are pretty limited because it's a one-line code. So it's a bit hard to write what you want to do. So instead of using Isosurface node, I am going to use a volume to do that. So let's get started. First of all, I'm going to create a boundary box for the shape that you want to create on inside. Let's create a box, and let's also create a null node to have all the parameters that you want to have as a parameter, so that you can control the shape later on. Right, let's first create a parameter for the size of the box, the boundary box, using a float vector 3. Let's name this size, or boundary box size. Any name is fine. Okay, and let's set the size to something like, it could be any value, but I'm just going to set it as something like this. And let's copy this parameter and go back to the box and paste it right here. Okay, and let's go back. Okay, why is it blue? Let me check the color. I'm not sure why this is drawn in blue. Well, never mind. Okay. Okay, now that I have a box, let's look back at the image right here. What I see from this image is that it is mirrored from the center point, and so the left side part and the right side part are symmetrical. So I would like to try the same pattern. Would like to make a symmetrical gyroid shape like this one. So to do that, I'm going to first create a left to right side part, then mirror it later on, then stitch it together with some operations. So let's do that. So to do that, I'm going to move this box to just on the left side or the right side. So let's move it to the left side, I guess. Left, I mean by x coordinate. Right, so for the center x, I'm going to just copy the size x, and then paste it right here with a negative value multiplied by 0.5, so that the edge of the box is on the 0 position on the x coordinate, right? And later on, I'm going to use the mirror to mirror this with a symmetrical image, symmetrical model. All right. Okay, so that's good for the boundary box. And let's create a volume out of this box by connecting this box to the volume. And I'm gonna initialize the value by 1 so that I can check the boundary with the volume, and also increase the uniform sampling divisions to a really big value like 100, so that I can create like a density or high res isosurface, I mean a gyroid. Okay. And later on, I'm going to trim out the surface using the same box right here, I think. So to do that, after I have converted the volume to polygon later on, then to do that, it's better to scale this boundary box a little bit higher so that it's going to be easier to trim out later on. So I'm going to use a transform node and scale this from the center of this box. So go to the pivot, transform, and type $CEX, which is the expression for the center of this box, and do the same for the y, CY, and CEZ for the Z. And then you can change this uniform scale so that the whole box will scale up or scale down based on the center point position. And I am just going to scale it up just a little bit, so I'm gonna just type 1.1 times. Right, now next thing, so the next thing will be the steps, which is going to be really important, and that is to create the deformed gyroid using a volume, using this volume. And as you might have imagined, I am going to use a vex to do the operations. Alright, so let me do that. Okay, first of all, let me just save this so that I don't lose the process. Oops. Okay, and what was it? So in order to control the volume value based on using the vex, you use volume wrangle, which is the wrangle node to control a volume values. So let's use this to control the values and open up the code editor using a Option E or Alt E. Okay, so first of all, let's try to create a simple gyroid shape like I did in Isosurface node. So that was, let's write up. Let's have a variable x, y, and z comes from the point position for the volume inside the volume. So the volume wrangle works on each voxels inside the volume, and each voxel has the point information or position information just like the point wrangle, like this. And you can calculate the new density using the same equations that I use, which was in Wikipedia. Where was it? This one? Yeah, later on. Okay, so this one. Okay, and sine x multiplied by cosine y plus sine y multiplied by cosine z plus sine z multiplied by cosine, oops, I think I made a mistake. So, okay, cosine x. Alright, apply, and in order to update the density of the volume, you just say f at density equals to this newly created value, like here. Right, so something looks wrong because I guess it's because of the range for the x, y, and z, since these have to be the angle value, but currently I'm using the the positional value itself. So currently, if the box size is 2 at x coordinates, so the value between the minimum and maximum is between 0 to 2 or 0 to -2, -2 to 0. So that is not enough for the angle, obviously, for x, y, and z. So it's a good practice to change these values into a angle. In vex, you have to use in radians instead of degrees. So let's convert this into a radians angle. And to do that, I'm just going to make it pretty simple. I'm just going to multiply this by pi, multiply by 2. So pi multiplied by 2 means 360 degrees in degrees. In radians, this is it's equal to 6 point something, 6.28 or something. Right, and that is equal to 360 degrees. And 360 degrees will make one continuous wave for sine and cosine. So do that. Say this is a constant value, and do the multiplication for all y and z as well, like this. And then you see some differences right here. See, it does seem like it is creating something similar to gyroid. So let's check this out by converting it into a surface from here. Okay, so in order to convert the volume into a surface, there are many ways to do that. One of the simple way that I found out is to use a convert volume node, which you can convert the volume into polygon. And if you connect it, you see something similar to what you have seen from the ISO node, Isosurface node. Now, the difference is that on the endpoint, especially on the side of the boxes, it is closed. So it doesn't really look like the one that you have shown in the Isosurface. It's a bit different. It is made as a closed surface, a closed polygon. So to make, and for this Isosurface, if you look at carefully, the surface right here, this is the darker surface, means that this is the back face of the geometry, back face of the mesh. And when you convert the volume to a surface, all these surface which is opened right now is closed to be solid surface. But in order to make surface like this, to make these side faces open, you have to do some kind of Boolean operations to trim these out, trim the side out. So go back to the convert volume, and to do that, I'm just gonna make it simple. I'm just going to use Boolean. You might be able to trim this out by checking the normal directions, but I think this is easier using Boolean, and make these first surface, make the first set A treat as parameter to surface, and then second to be a solid, and to the second input I'm going to input the box right here. Okay, and make the operations to intersect, and as a result you should see something similar to the Isosurface node that you have used. Alright, looks good so far. Okay, and let's name this to Deformed Gyroid. Deforming Gyroid. Now, currently I'm not deforming right now. That's the next step that I want to do. And before doing that, let's also have some parameters in order to control the resolution of this gyroid shape. Currently it's fixed based on the position of the point of the voxels. So to control the density, what you need is some additional parameters right here, multiplied by some values. So if you multiply it by, say, 1.5 and apply it, you see that only the x direction has more density. If you make it 5, you have more density on x direction, just on x directions, but not on y or z. So you can either have individual parameters for all x, y, and z, or make the same global parameters for both, for all x, y, and z. For this one, I'm just going to reduce this number of parameters. I'm just going to make one resolution parameters in order to control the density. So let's say I'm gonna name this res angle, or res, just gonna call res. Okay, and let's name this resolution res, and okay, and gonna say apply, promote the value resolutions, and set the value to 1 for now, and then multiply these resolutions to all x, y, and z. So if you want to have more control, you can have 2 more parameters in order to control y and z individually. But I am going to skip that process to make it a bit simple. Okay, let's make the range of the resolutions to, say, from 0 to 5 or 3 or maybe 5 is fine. Okay, and let's check the differences by controlling the sliders. Okay, maybe that's too dense. Maybe from 0 to 2 is okay. Yeah, that's too dense. It's a bit hard to see. Okay. Alrighty. Alright. So far so good. Now next thing I would like to do is to think about how you can actually deform the gyroid to something like this one. Now by looking at it, I felt that there are some at least two deforming operations done in here from the basic gyroid. One is a kind of a shifting of the, in this case, y. If the horizontal axis is x and the vertical axis is y, then I do see some shift on y-axis based on the position on x. So from the center to the side, seems like the gyroid shape is shifting downward, like these, like downward, like these. And also I do see some rotational deforming operations right here as well. Not just a rotation, I guess, but maybe rotation and scaling as well, but I do see some mainly a rotational deformation right here as well. So I focused on these two deformation operations, so that's what I'm going to try to implement using this volume wrangle in order to deform this simple gyroid shape, which is still an interesting shape, but let's make it more interesting. Okay, let me save this and go back to the volume wrangle, open up the code editor, and let's try to do the shifting part first. So in this case, I am going to, so the vertical axis currently right here is the y-axis, and so let's try to shift this whole shape based on y direction based on the x coordinate value. So the x coordinate value for each voxels, the x starts from here, which is equal to 0, and then goes to minus something like 2, minus 2 right at here. So that's the minimum value. So based on those minimum maximum value, I would like to change the y value for this shape. Right? So in order to do that, I was thinking what I could do is to first carefully look at the equations written right here. So, and there is a big hint written right here. You see that this equation is, in order to create this kind of shape using these equations, it's primarily using just x, y, and z for the parameter inside the sine and cosine. So I thought if you could change the value inside these sine and cosine trigonometry functions like x or y or z, then you might be able to control the whole shape as well. So if you want to shift the y value, then why not just shift these y value which is used in these equations? So that's what I wanted to try, and I have already tried and it worked just fine. So let me just show you how you can do that. So in order to shift this y value, it is actually pretty simple. You just need to add some additional value right here. Let's say a to a y value. Okay, and let's create this a value. Maybe let's call the shift value. Right. And you want to create some variable called shift. And this shift value, I want this shift value to be based on the position of x. So x coordinate, which is equal to this one right here. Or maybe just this one before multiplying with these angle values. So let's just use at p.x, which is the voxel coordinate information. And let's just try with this value and see if you see any differences with the shape. And apply. And as you might have seen, there are some changes by adding this shift value to the y inside the cosine and sine right here. If you didn't see any changes, let's multiply this to make it a bit bigger values. And yeah, now it's pretty obvious the y value, the y direction is obviously shifted by just adding this shift value based on the x coordinate of the voxel. So as you can see, the deformation itself is pretty simple to achieve because of this simple equations. So let's, in order to control how much you want to shift the y value, let's also make this as a parameter. So let's make this a parameter shift, how much you want to shift it. Apply, promote the value right here. And for this one, maybe you can set the minimum maximum from 0 to 10. Right, and apply. And let's try to change this parameter. And yeah, it is changing the y-axis value like this, which looks already a bit interesting. Right. Now, one more deformation that I want to achieve is the rotational deformations, which might going to be a bit more simpler than this shape. Maybe there are more deformational operations used in this shape, but I'm gonna just make it simple. I'm just going to apply one more transformational operations, which is going to be the rotation. Right, so let's think about how you can apply additional rotational deformations to the current setup. So as you might have seen, by using the shift value based on the x and adding to the y direction, just make you the shift to the y directions. So making the rotational deformation is also pretty simple to do. What you need to think about is that these x, y, and z value itself is initially based on the voxel positions, because these are just using the voxel positions as a parameter. So if you have modified these point position previously, maybe rotate this point position with some angle, then use the newly rotated point position for this with these equations, then you might be able to get the rotational deformed geometry with an isosurface. So let's try that out. First, try to rotate the point position using some rotational matrix. Then use that new point position together with this equation and see how it's going to what it's going to make, what kind of shape it's going to make. So it's going to be fun. In order to create a rotational matrix, I'm going to first create a ident matrix, which is just the identity matrix, and then use the rotate function to create a rotational matrix by using some angle, how much you want to rotate. Then you also have to set some rotational axis, and in this case you might want to rotate this shape like this direction, or this direction, clockwise or counterclockwise, and that direction, the axis of this rotation is z-axis. So let's set the axis to like z minus z-axis. Could be also a positive, either way is fine, I think. Then we still don't have this one yet. We have to make it as a parameter, I think. Now after we have created a rotational matrix using this function, then we can create a new position, say our pos, by rotating the at p multiplied by this matrix. Alright, so this, after doing this one, okay, I need to have an angle. So let's also create a parameter for angle. Like this. And promote the angle parameter. And this angle parameter should be in radians, so it might be better to multiply this angle by, say, pi or something. Right. And use this angle value to rotate this point position. Then let's try to replace this at p with this our position right here and see how it looks like. So it is using this the axis as a rotational axis and rotating on clockwise or counterclockwise. I'm not sure which way. Let's see how it looks like. Okay, so replacing this is end pos, not the end pos, our pos. So our pos, and how does it look like? Okay, I do see some exaggerated pattern right here. Now it seems like whole shape is rotating in same manner, so that's not really what I want. I guess the angle that I want to achieve is based on the x direction and also on the y direction as well. So meaning higher x value you have, maybe you want to have higher angle in order to modify, or higher y value you have, you want to have more higher angles to rotate. So, and currently this is the constant angle in order to rotate, so this just give the whole shape to rotate in the same manner, so that's not really interesting. So in order to achieve the angle based on the value of x and y, maybe I can just try multiplying this with at p dot x multiplied by at p dot y, and let's see how it looks like. Now something interesting happened. Something interesting things have happened. Okay. When it goes to 0, I think nothing happens because there's no rotation. Maybe keep the shift to 0 as well so that I can see it better. So let's increase the angle. And you see that based on the x direction, x coordinate and y coordinate, the shape is rotating in this way, and more value you have, more exaggerated results you get. So when you have this kind of artifacts, maybe you want to have more detail for the volume, or maybe for the convert volume, make it the detail level to something higher than 1, which is going to make it a bit too slow. Maybe I want to cancel this. Let's make this 1, and maybe set the uniform sampling divisions to 150. Still a bit too slow. Yeah, a bit better, but I'm gonna keep it with 100. So I'll try not to create this kind of too detailed pattern at this point. Okay, so let's try to reduce the angle value right here, close to 0. But as you can see, it gives you a really interesting result, even with this very small numbers, which you can also use the negative value to rotate in different directions. So in this case, this is rotating in this directions, but if you make the negative value, I think it rotates in this directions. So let's see how it goes. Alright, this is also interesting. Yeah. Alright, and actually I am going to trim out the side. Oops, that's too much. Actually I'm going to trim out the side part right here using another geometry that I'm going to use for base boundary geometry, so no need to worry about the artifacts that much. Okay, well, let's also set the range for this angle. Maybe from minus 0.5 to 0.5 is good enough. So minus 0.5, negative 0.5 to 0.5. That should be enough. Alright. Alright, okay. Interesting. And if you have this deformation together with the shift, this gets more interesting, like this. Alright. Now, as you can imagine, you can have more deformation based on z direction, y direction, or x direction just by changing these x and y and z, and set it inside a sine and x and sine and cosine parameter right here. So it's the matter of your imagination. Just imagine how you want to deform the geometry and try to create that deformations previously and decompose it into x, y, and z, and just re-enter this newly created x, y, z to write these equations, and voila, you get new deformed gyroid. Right. And for this one, I am pretty happy with this result. I could also try, maybe I could also try changing some of the parameters. Maybe if in the example that I have posted on the GitHub, I was using a original voxel coordinate for Y and Z, and I am just using X. I'm just using the rotational coordinate just for the X value right here. Let's see the difference. And yeah, it is still interesting. Let's see how it looks look like if I change the adjust the Z value, just this direction. Doesn't really make any changes. So that's okay. How about the Y? Yeah, it gives you a bit more exaggerated results. So I'm gonna go with at P and just gonna use rotated X. Well, at P dot Y. Okay. All right. So okay, apply, accept. So this is pretty much all for the deformation. I'm pretty satisfied with the result. So the next thing I would like to do is to create the final shape by using something like mirror and trim out the side pieces using some geometry for the trimming. So let's do that. And that is going to be pretty simple operations. First of all, I'm going to use a mirror node. Okay, thank you for the comment, everyone. Maybe you want the background music as well. Maybe next time I can try to find out the free to use sound. Maybe I can download from YouTube. Right, and yeah, it already looks interesting by just mirroring it right here. I liked it. Maybe I want to make it as a logo for something. Alright, cool. Let's try to... Okay, since I already have 3 parameters right here, let's also promote this to this node controller so that I can control these later on. Go to the edit parameter interface for the node controller and go back to the deforming gyroid volume wrangle. Let's check off this 4-bit linking parameter outside of subnet. Drag and drop all these parameters that I've created and apply. Now I am able to control this shape from this node controller. Now it is a bit slow to create because I'm dealing with the high density volume, but the result is pretty promising, so never mind about that. Yeah, I like it. Alright. Okay. So currently I do have some artifacts right here when on the connection edge, so I want to remove that. So to do that, first I'm going to merge the overlapped vertices using fuse, and after this I'm going to smoothen out the surface using either smooth node or attribute blur. In this case, attribute blur works well, I think, so we'll use this one. And gonna check off the pin border. I think I don't really need this, or maybe well, I guess having this pin border is fine. Then set the blurring iterations to 10 or something. Yeah, the edge looks a bit more prettier. Alright, looks good. Looks good. Now, currently I do see a color differences between this face and this face, because one of the faces facing front side, this one of the faces the back side, so it has a different normal direction. So to make the whole surface white, you have to have the front face for both sides. So, and if you want to create a 3D printing geometry from this kind of shape, you have to have a thickness as well. So let's try to give a thickness to this geometry by using poly extrude. Well, just using a poly extrude might not give you a very pretty geometry, but let's try to do this. And I'm gonna use a point normal instead of a primitive. And let's try out the distance right here. Maybe I can make another parameter inside the node controller for the thickness. Let's bring this down. Let's bring this down. Okay. Let's name this thickness from 0 to say 0.1. Copy this parameter and then paste it right here. Okay, and I also want to close the backside by checking this output back. Now you have a extruded geometry like this, and now I think it's possible to 3D print as well. Maybe some of the faces has an self-intersected right here, so if you really want to make it as a 3D printing geometry, you might want to convert this into a VDV from polygon and set the voxel size to a small value like 0.015 or something. Okay, now convert back to polygon so that you have clean closed geometry, not the curve. Alright. Okay, now I will also like to trim this whole geometry out so that the shape will something looking like this. Maybe not exactly like this, but currently the shape is too square, too boxy, so I'm gonna make a base geometry in order to trim this whole geometry out. And to make it simple, I'm just going to make trimming geometry based on a sphere. So first of all, I'm going to create a sphere, which is this with the polygon parameter. Make the frequency a bit high. Let's also show the edges. Okay, maybe I might want more edges. Okay, and I'm gonna keep the whole size to be 1, but currently the whole size, the diameter of this sphere currently is 2, so I want to make the diameter of this sphere to be 1. So I have just scaled this to 0.5. Now, first thing I want to do is to fit this sphere inside this bounding box that I have right here. Or maybe not to this bounding box, but bounding box from the whole output, which is this one. So maybe I can create a bounding box out of this gyroid shape, and then I want to fit the sphere inside this bounding box. And I guess you can use a transform node using with expressions, but let's just use point wrangle because I'm pretty familiar with this one. Okay, it's just going to be a simple code. First of all, going to get the size from the bounding box, size information from the bounding box using the get bbox size from the second input, then multiply the sphere size with this size. Alright, so that was easy. Okay, I have a question. Could it be that with the reference they remap most the voxel grid into the particular shape rather than trimming a deformed gyroid formation? Could it be that means I think it's also possible using a reference to make the particular shape inside a voxel. I mean the volume node right here. So maybe you can, if you have some geometry to use for the reshape and connect it to the second input for the deformation gyroid, then use it for some, use it in order to use it as a guide to deform the shape. That might be also possible. But since I haven't tried it out, it's a bit dangerous to do it in live, so let me skip that out. But if you're interested, I could try this out later on. Right, so I have this sphere geometry right here, and just using a sphere as a trim geometry is not that interesting, so I'm going to also modify this sphere shape to something a bit more interesting. Right, based on the x, y, and z coordinate of this sphere, this newly created sphere. Okay, so I guess I could use some kind of a wavy function like a sine wave to modify the section shape of this sphere, looking from the top or looking from the side view or from view. Right, let's do this. Okay, so first of all, let's try to change the front side shape. If you look from the top, I want to convert the shape into something like wavy shape for front side and back side as well. So for that, I can use this x coordinate as an angle to create a sine function wave, wave. So first of all, in order to do that, I'm going to create an angle x, retrieve from an x coordinate, and currently the x coordinate is from the minimum value of this bounding box to the maximum value of this bounding box. So let's get the minimum maximum of this bounding box using get b box. Wait, get b. Yeah, just get b box. Okay, and from the second input, you can have minimum maximum feed it inside this vector value, vector attribute. Right, so I can remap this x coordinate of sphere from a minimum x to maximum x. This is the source range, and for the new range for the sine function, I can change it to from 0 to say pi if you want to use a sine function. Then let's I would like to change the z direction in order to change the shape we're looking from the top. So let's name this x scale z, and that can be calculated using a sine function with this angle x, right? And finally, I can try to modify the z value by multiplying this scale z to z coordinate. And now I have a shape like a lemon, which, well, I'm not sure if that's interesting, but it's okay. Okay, let's do the same for the y direction as well. So let's create the coordinate. Let's use the coordinate y as a angle in order to create another function. And this times maybe trying to use a cosine might be interesting. So let's do that. Okay, so let's do this above. Let's do this below the z. So float ang y is equal fit at py, which is from minimum y to maximum y. And in order to use the cosine value to have one continuous mountain-like wave, you might need to use from 0 to pi multiplied by 2. Okay, and create the scale y. Wait, is that correct? Maybe not. Maybe this is still scale z, because I want to control the z coordinate in this case. So let's keep this scale z. Just gonna update the scale z right here, scale z, and using cosine ang y. And as a result, you should be able to get a value from 1 to -1. So let's change this ranges from, so degree 0 means degree 0 used for cosine gives you 1, and degree 180 degrees will give you a value -1. So you wanna fit it like this from 0 to 1. Then multiply the z again with this new scale z. Okay, wow. Wow. I don't know if I like this shape though. Maybe the thickness of the z direction is too much. Let's reduce the box size right here to 1.5. Yeah, a bit better. And maybe I can also add some parameters in order to control the scale ranges by having like power parameter from 0 to 1 or 0 to 2. Maybe set it to 0 to 2. Then use the power function to control one of the z scale. And that gives you a bit more interesting. Oops, that's too much. Okay, let's do this for this one as well. Wow. I guess you can do a lot more using like noise function and so on it's really up to you, but I'm just gonna go with this one. This is just a guide geometry in order to trim out the gyroid surface, so you don't really need to do much about this one. Okay, now say I am satisfied with this shape. Let's try to use this to trim out the shape. Since I am using VDV at this point, maybe I can convert this into VDV as well. Now let's just copy this VDV from Polygon, and then use VDV combine and use the change the operations to SDF intersection, and now you have something interesting shape. Some interesting shape. And if I change the power value right here, now the surface that I made at here, it's not that interesting, but combining with the gyroid, it looks a bit more interesting. Yeah, I like it. Really looks like a logo now. Alright. Let's also have this power parameter inside here as well. Let's check this off and go back to this scale sphere. Let's name this shape power. Alright, now time to convert this into polygon, and voila, that's pretty much it. Let's try to add some friction, and let's also try to change the color for these one and finish this up. Let's make the diffuse to a bit more lighter color. Okay, so the whole concept, how to deform the gyroid, is already done at here. So anything underneath here, below here, is just optional operations in order to make it a bit more prettier. So in general, it's pretty simple. Yep, like it. It's just a few deformation, just gives you a really interesting shape, which I think it's really interesting. Yep. Okay, for the last part, maybe some of the geometry looks a bit jaggy. I could use another smooth node like attribute blur, additional attribute blur. This one with a bit higher iterations. It's pretty up to you. And let's also colorize this using point wrangle based on the normal direction of the surface, and I will finish this tutorial up. Okay, so first of all, I'm going to shade this whole shape, whole geometry based on the normal directions. So if the face is facing down, then I want to make it darker. If it's facing up, I want to make it brighter so that it looks like it has some ambient occlusions. Right, so first, in order to do that, I am going to first calculate the dot product between the normal direction of the point together with the sun direction. Say the sun is coming directly from top to down bottom using a negative y direction. Then use this dot value, maybe convert this dot value, since the dot value gives you from -1 to 1, Let's fit this to 0 to 1. Just in case it's not gonna give you an integer, I'm gonna add the point. Okay, and right here I can try to create a color value. Currently the color value is white, I think, so multiplying it by dot. Let's see how it looks like. Now this is opposite. The top part looks dark, the bottom part looks light, so I guess I could make this one positive. Okay, so currently the bottom part looks darker, top part looks brighter. It looks like it's having some shade. Okay, now I can add another additional color parameters, maybe to add some color to this one. Maybe based on the y direction. So I would like to get the bounding information of this y value. So let's give another bounding box right here. Connect it, or maybe I don't need this. I can just use a get bounding box functions. Okay, would be amazing car grill or flower pot. Cannot help but think of using this in real world somehow. Yes, please try to use this in some of your products in real life. Maybe it might be really interesting. Really like to see that happen. Could be really beautiful using this with a porcelain or something. I think you can do that in 3D printing. Other than that, I'm not sure if it's possible to do this, but creating this in metal might be really interesting as well. Would also want to try this. Alright, so let's get the bounding box information. Wait. First min max and get b box from first input and min max. Okay, and let's get the y value, which is point at p point y, and let's convert this into 0 to 1 range by using fit. So minimum y to maximum y, this is the source range, and 0 to 1, this is the target range. And let's have a 2-color value in order to create a gradation from bottom to top. So to have a color parameter, I think I have to go to the edit parameter interface and then give a color value, or maybe I can just use this ramp color right here. Is this the correct position? Yeah, I think so. And say color. Right, and then let's also link this with this controller. DDD 4-bit linking parameters, and drag and drop this color node, color parameter to here. Okay, now in order to access this color value right here, I think you can use a ch ramp node. That was it. Was that it? I think you can ch ramp. Was this the value? Yeah, I think this is the one. And the name was call, and use this y value in order to get the color value. And After that, I can multiply this color with this CT. Right, so let's try to change the color. Rotation. The bottom part, let's say I want to make it red. The top part, let's say I want to make it yellow or green or blue. Let's make it bluish. A bit darker. Let's make it a bit darker. Yeah, maybe too dark. Okay, so this is pretty much it. How you can create a shape with a deformed gyroid, starting from the simple gyroid. Okay, I have a question. There are a few artifacts in the mesh rectangular. How we can get rid of them? You mean after converted into mesh from convert from a VDB? I guess after converting from a VDB, you have less artifacts compared to converting from just using direction this geometry poly extruded directly. Well, if you still see some artifacts converting from the VDB, maybe you can apply some VDB smooth in between before converting into a polygon. Make it small iterations like one, and that might give you a bit better result. Well, I do see some artifacts right here. Yeah, this is, yeah, that's not really doesn't look good. Maybe in that case I can increase the thickness a bit more. Maybe 2.05. Yeah. And if you still see some artifacts, you can increase the smoothness for this VDB smooth. And yeah, I still see some artifacts right here. Yeah, it's really up to the how much solid faces you have when you do this poly extrude. So at this point you have several artifacts right here, but so I guess it's a matter of trying to find the best parameters for your case. If it's make it too thick, maybe it might be okay, but might not be really beautiful. And that looks too thick. Well, yeah, I don't like this part, but I think you'll get it at some point where you controlling some of the parameters like smooth and so on. Okay, so that's pretty much it with this tutorial. Let me know if you have any questions with this one. I would like to answer it. And let me just play with this one by changing some of the parameters. Yep, like it. Yep, even changing the thickness, increasing the whole resolutions will still give you some interesting geometries. Right. So using this technique that I explained here, you can do much more with this gyroid shape. Maybe not just gyroid shape. If you search for another kind of isosurface geometries, you could do pretty much the same operations, same kind of deformations, just by replacing x, y, and z with deformed x, y, and z. So let me just show you one of the example that I tried with that concept. There's one that I tried, which is a bit more simple, but you can even create a gyroid which is placed circularly like this. And this could be maybe used for lampshade or maybe flower pot or something as well. Maybe there are a lot of use case for this one as well. And you can also set some parameters for this one. Like changing the loop number for the circle. If you increase this, you have more surrounded gyroid shape, circular shape, repetitive circular shape. You can also control the density on the density from the center point to outward direction. So if you decrease this, you have less density. You can also control this density for the height. Yeah, so that's just one example that you can do with this deformation operations. Right. Yeah. Also, this is pretty simple, but I do like the output shape. Alright, so that's pretty much it. If you have any questions, I'd like to answer it, but if not, I would like to end the tutorial at this point, which I have spent like 1.5 hours. And thank you very much for watching it. I do appreciate it. I do appreciate that everybody's come here to watch this. Yes, thank you very much. And I would like to I'm thinking to do another tutorial live next week as well with some other topic. Hopefully I can find something interesting for myself. Right. So I guess there are no questions right here. Let me end this live. And I will save the archive for YouTube. I am not sure for Twitter and Facebook. I might not. I might gonna delete that. But you can always watch the archive from YouTube. So if you're interested, if you want to rewatch it, you can come back to the same URL and also can download the file. Let me also save the file that I have created online right here as well. It's pretty much the same as the one that I have uploaded previously, but just in case some part might be different. Okay. So that's it. Thank you very much, and hope to see you next week as well. Right. And thank you very much everybody for the comment as well. We do really appreciate it. Right. So good night, goodbye, and thank you. Right.